Alright, hi everybody, this is homework 2.12. This homework is actually due on Tuesday because remember I will not be there on Monday, so you have a little bit longer, which is why this homework is also a little bit longer. So let's start with problem number one. Problem number one says a car has a 16-gallon fuel tank. So that's how much fuel is in the tank. When driven on a highway, it has a gas mileage of 30 miles per gallon. So each gallon will get the car 30 miles. All right, per gallon. That gives us a good hint as to what operation we're going to use. The gas mileage, also called fuel efficiency, tells us that the number of miles the car can travel for a particular amount of fuel. So for 1 gallon of gasoline, you can go 30 miles. After filling the gas tank, so we have a full tank, so we've got 16 gallons, the driver got on a highway and drove for a while. How many miles has the car traveled if it has the following amounts of gas left in the tank? So, first of all, we see for 15 gallons, originally there were 16 gallons, which means we can do 16 minus 15, right, equals 1. Only 1 gallon was used, and if 1 gallon was used and we can go 30 miles per gallon, and we multiply, again, that 1 gallon times 30 miles per gallon, that's an easy, this person has traveled 30 miles. Okay, now let's look at 10 gallons. So 10 gallons we've used more, right? So if we have a 16-gallon tank and we've used 10 gallons, that means we have 6 gallons left. And then we're going to take that 6 and multiply it by 30 miles per gallon. And we will get 180 miles. That makes a lot more sense, right? Because we used more gas, we should be going more miles. Now, in this case, we have only 2.5 gallons left, which means we've used a lot more gallons here. So if we say 16 minus 2.5, we would have 13.5 gallons left, 13.5 gallons that we've used times, again, 30 miles per gallon. That'll tell us then that we've gone quite a long distance. This should be our greatest distance. You can use your calculator or you can go ahead and work it out on your paper, but you will get 405 miles. Okay? So again, we're looking at how many gallons you have left here, and then using that we can figure out how many gallons were used, and then knowing that they can go 30 miles per gallon, we can multiply to figure out how many miles we went. So, if we're writing an equation to do that, we know that we have the 16-gallon fuel tank to start. And then if we're saying the amount of gallons left, we can subtract that to find out how many gallons we've used. And then we're going to multiply that by our fuel efficiency, or our rate of 30 miles per gallon. And that will give us our distance, how far we've gone, right? Again, looking back up at here, what we did here, that's what we did. We went ahead and said, well, we have 16, then we subtract how many gallons are left to see how many we've used, and then if we multiply that by 30 miles per gallon, we can figure out how far we've gone. So now, in this next part, it's asking you instead, how many gallons are left if we've gone this distance, okay? So now, instead of replacing this for x, we're replacing this for d and solving for x. So let's zoom in a little and take a look at that. So if we were to do 16 minus x times 30 equals 90 miles. Okay, now remember we talked about this a little bit in class on Friday. Here you have an option. You can distribute this 30, or since we know 30 goes nicely into 90, we can go ahead and divide both sides by 30 to cancel out that 30, okay? And so 90 divided by 30 is going to be 3. We're going to get 16 minus x equals 3, okay? I'm going to go ahead and subtract 16 from both sides, okay? And we're going to get negative x equals negative 13, and therefore, if we divide both sides by negative 1, we'll get a positive, which will be x equals 13, okay? So if the car travels 90 miles, they will have 13 gallons left in the tank. That makes sense because they would use 3 gallons to go 30 miles per gallon. They would use 3 gallons to go 90 miles. Okay, so try the same thing for part 2 with 246. Go ahead and plug that back in for D and solve for X to see what you can get. All right, let's take a look at this last part. It says write an equation that makes it find it easier to find the amount of gas left in the tank X if we know the car has traveled D miles. So if we know D and we want to solve for X, so again we have 16 minus X times 30 equals D. And if we want to solve for X, again, you can distribute the 30 through, or you can go ahead and just divide it initially. Remember, 30 divided by 30 is just 1. So we'll have D over 30, and then we'll have 16 minus X equals D over 30. Okay? Now, we want to move the 16, so we're going to subtract 16 from both sides. Okay, it does not have a common denominator yet. We can make one, but we're going to go ahead and just subtract it from that fraction there. And then 16 minus 16 will equal 0. All right, so now we have negative X equals D over 30 minus 16. I'm doing this one with you because this part you have to be careful. Because we have this negative here, okay, and we want to have just X, we need to divide by or multiply by negative 1. Because when we multiply a negative by a negative or divide a negative by a negative, it will make it positive. But remember, whatever we do to this side, we also have to do to this side. So I'm going to change colors here just so you can see this. So let's go ahead and say we multiply by negative 1. Again, we have to do that to both sides, the whole thing. So a negative times a negative, right? This negative times a negative will be a positive, and that will go ahead and will yield positive X. Okay? And then now we have to distribute this negative 1 through this equation here. Oops, I didn't mean to cross that out. Through this equation here. So we will end up with a positive 16 and a negative D over 30. So if we want to write that a little bit neatly, we can write it as 16 minus D over 30. Okay? Or you could write it as negative D over 30 plus 16, but it just looks a little bit nicer when we have our positive first and we're subtracting from the 16, which would also make sense because we're subtracting from the number of gallons originally. Okay? All right. Number 2, the area of a rectangle is represented by the formula A equals LW, where L is the length and W is the width. All right, anytime you have the area of something, there's a shape, you need to draw it. All right, so let's go ahead, draw our rectangle here, and we're going to say we have L, this is the length, and W is the width. The length of the rectangle is 5. All right, so let's say this is width, length, okay, and we'll say length equals 5. All right, I'm writing the little cursive L because sometimes you all confuse my L's with 1, so we want to make sure that's clear. All right, so if we are looking for A equals 5W, and it says now let's make it easy to find the width. So if we want to make it easy to find the width, to get the width by itself here, we have multiplication happening. Right? So our opposite, our inverse of that is going to be division. So we can go ahead and divide both sides by 5, and you will get W equals A over 5. You could also write that as W equals 1/5 A. That would also work. Okay? All right, let's look at number 3. Noah is helping to collect the entry fees at a school sports game. Student entry costs $2.75 each. And adult entry costs $5.25 each. At the end of the game, he has a nice big total of $281.25. All right, so we have, if we look at here, it has A's and S's. So we know that that's A is adult and S is student. So let's go ahead and write an equation for that. Let's say we have $2.75 times the number of students plus $5.25 times 525. I still have eraser on. Let me go and fix that. There we go. 525 times adult. Okay? Equals a total of 281.25. Okay, so that's our initial equation. Now it's asking us which of these equations down here could also represent that relationship between the number of students and the number of adults. All right, so this first one is saying if we have 281 minus 525a equals 275, would that work? Well, if we look at our original equation that we made here, if we subtract 525 from both, 525a from both sides, this is something we would get. So we can say, yes, A is correct. Okay? So letter B says A equals, so this is solving for A. So look at your original equation. I'm not going to go through this whole thing with you. You can do this. Look at your original equation, solve for A, and see if that equals 53.57 minus 275 divided by 525s. All right? Try that out. See if that makes sense. See if that works for you. All right? Same thing, letter C is also asking you to solve for A. So you want to see, if I solve for A, what am I going to get? Does that make sense for us? All right? Letter D is having us solve for S. If we solve for S, is that something that would work out? Is that something that would be equivalent? And the last one, again, is having us look at another way to look at A. So again, you want to see if that works, if that makes sense, if we solve for A. Right, notice that A is being multiplied by something here, okay? Which should give you a hint about what your final equation or what another equation might look like when you're solving for A. All right, so number 3, I want you to go back and look and see what are all the equations that could represent the relationship between the number of students and adults. All right. Number 4 is an equation to calculate the volume of a cylinder V, where R represents the radius of the cylinder and H represents the height. All right, so remember, cylinder looks, somewhat like this, okay? All right, so we have V is the volume, R represents the radius of the cylinder, that's R, and we have H is the height. Which equation allows us to easily find the height of the cylinder because it is solved for H? So we want to solve for H. Our original equation is V equals pi r squared H. Now let's solve for H. In order to get H by itself, this right here is multiplication. So I'm going to divide by pi r squared on both sides. Pi r squared divided by pi r squared will be 1. So we'll be left with H. H equals V over pi r squared. And so this is an R. That doesn't look like an R. There you go. So C is going to be our best answer. All right. Number 5 says the table shows the volume of water in cubic meters V after a tank has been pumped out for a certain number of minutes. Which equation could represent the volume of water in cubic meters after T minutes of water being pumped out? So really what you're doing is, here is T, here is V, and you want to go ahead and plug these numbers into these equations to see which equation will work. Again, something that you 100% completely can do without me. So go ahead and plug those numbers in for V and T, substitute, right, and see what you get. All right. Catering company has set up for a wedding. They have 150 people. They can provide small tables that seat 6 people and large table that seat 10 people. Find a combination of small and large tables that seats exactly 150 people. All right, so first things first, you're going to want to go ahead and set up a little equation here. So if we have small tables, so let's say 6s, 6 times small tables, will give you 6 people. And then large tables give you 10 people, so 10 large equals 150. So we want to see what numbers could we plug into S and L that would give us 150, right? So go ahead and try some numbers. Play around with this. See what you get. For example, if I put 2 small tables and I get 12, if I subtract 150, 12 from 150, do I get a number I can easily divide by 10? Right? I know, for example, that if I multiply 5 times 6, I'm going to get 30. That leaves me with a nice even number. I would have, let's say I have S equals 5. That's 30 people. Subtracted from that, I'm going to have 120 people I still need to seat. If I divide 120 divided by 10, I get a nice even 12. Okay, so then I would have small tables being 5 and 12 large tables. That's something that would work. You might come up with a different combination. That's perfectly fine. There are several options here, but you want to go ahead and see what works best for you. Okay, or that works in the equation. All right, so B says let X represent the number of small tables and Y represent the number of large tables. Okay, so we're going back to our original equation, and we're just saying 6X plus 10Y equals 150, right? Just changing out that S and that L. And then it says explain what the point 20, 5 L means in this situation. So thinking about the graph, what would 20 for the value of X mean and 5 for the value of Y mean? Again, you can answer this one. And then D says, is 20, 5 a solution to the equation you wrote? Explain your reasoning. So plugging in this point, is that a solution? Yes or no? All right. This one right here, number 7, solve for X. Okay, I'm going to start the beginning part of this, and then I want you to continue on and see which of these equations work. So we have 10X minus X plus 5 equals 41. I immediately see that I have like terms here, 10X and 1X, right? An X. So I can go ahead and make that 9X plus 5 equals 41. Subtract 5 from both sides. Show that work. 9X equals 41 minus 5 is going to give us a nice 36. Divide both sides by 9. X equals 4. Okay? So with X equaling 4, which of these equations are true? All right? We also, because we did all of this work right here, you can look here and see what matches up here that makes sense and what doesn't. All right. Your last page, third page. Again, this is 3 pages long. It's not due till Tuesday. So if you don't finish this whole video and you want to pause and save some for tomorrow, that's fine. You can do that. All right, so we have Noah. Noah is solving an equation, and one of his moves is unacceptable. So he did something wrong. Here are the moves he made. Okay, so first, he has his original equation. Then he applies the distributive property. So he distributed the 2 through the parentheses and made it 2x plus 12. Okay, that so far looks good. Then he combined like terms. So he combined his 12 minus 4 and made it 8. Okay? Still looking good so far. Then he said, subtract 8 from both sides. Okay, so he subtracted 8 from both sides, and his 8's canceled out. Okay? Then he divided each side by x. Okay, we've seen equations like this. We've seen problems like this. What did he do wrong? Okay, instead of dividing each side by x, because that gives us an answer that doesn't work, but if we look at 2x equals 6x, there's an obvious answer, right? What did he do wrong? Read through carefully A, B, C, and D and answer what is it that he did. Number 9, Liz says that a solution to the equation 2x minus 6 equals 7x must also be a solution to the equation 5x minus 6x equals 10x. I want you to tell me, why is this true? Why could this possibly be true? All right, so think carefully. Why would that equation be true? You can figure this out. Think about what x equals. Think about what x equals and think about whether or not that would be accurate or not. All right? Okay. Let's take a look at this last part. So this last part is asking you to solve the literal equations for the requested variable. So this first one asks you to solve for a. So you have z equals b plus m divided by a. And we want to rework this to get a by itself. So the first thing I see here is that I have a b plus m over a, and that b is positive, right? There's no plus in front of it, but I know it's positive. And so to cancel that out, I'm going to go ahead and say, all right, let's subtract b from both sides, okay? Minus b. All right, b minus b is going to be 0. That's going to cancel out. Z minus b, they're not like terms, so we are just going to leave it as z minus b equals m over a. Well, now I still need to get a by itself, right? and I want to get a out of that denominator. So I'm going to go ahead and multiply both sides by the a. A will cancel out on this side. And now on this side, I have a times z minus b equals m. Okay, let's rewrite that just so we can see it a little bit better. Now again, I still want to get a by itself. So my next move is going to be, I could distribute, but that's not going to help me to get a by itself. A is almost by itself. It's very close to being by itself. So I'm going to go ahead and divide both sides by z minus b. All right, and this then, z minus b over z minus b, it's going to cancel out because it's 1. Whatever that would be 1. And so we're going to end up with a equals m over z minus b as our answer. Okay. Let's try number, actually we're not going to do number 16 because you can do this one by yourself. You're solving for x. You want to isolate x. Remember, you've got a lot of different terms there, not like terms, unlike terms. So think about what you need to do to get x all by itself. 17, same thing here. We're solving for a. We want to get a all by itself. That first thing we want to do is get rid of this, okay? Get rid of that. Think about how you're going to get rid of that, and then isolate that a. I am going to go over number 21, and then I think the rest you can handle on your own. Let's try 21, though. So 21 is asking you to get x by itself, okay? The thing is, we have an x in the numerator and an x in the denominator, so this might be a little bit tricky. Let's see what we can do. All right, so first things first is, if we have g equals x minus c over x, you can actually go ahead, if you want, and try to break this up so that we are separating this fraction. So we can say g equals x over x minus c over x. Okay? Now, x over x is just going to be 1, so this is g equals 1 minus c over x. Now this makes this a lot more palatable, a lot easier to get that x by itself. So, of course, I'm going to go ahead and subtract 1 from both sides first. So that will cancel out, and I will end up with a g minus 1 on one side equals negative c over x. All right? G minus 1 equals negative c over x. All right. Now, again, I still want to get that x by itself, so I'm going to go ahead and multiply both sides by x. All right? And I'm going to get x times g minus 1 equals negative c. These are going to cancel out. X divided by x is 1. All right. Now I need to get x by itself. So this is very similar to that first problem. And to do that, x is very close to being by itself. So I'm going to go ahead and divide by g minus 1 on both sides. And I'm going to, this will cancel out, okay? Because it will be g minus 1 divided by g minus 1 is just going to be 1. So we're left with 1x equals negative c over g minus 1. If you want to clean up those negatives a little bit, you can. You can do that by putting the c over the g, separating it out like we did with the fraction above, and making it negative c over g and negative c over negative 1. But you can also just leave it the way that it is right here because we have solved for x. Okay? All right. If you have any questions or you need any help, you're welcome to message me or comment on the video.